In this video, let's practice on how to find an arithmetic series. In this practice, you can see that each term in the series is an expression involving variables p and q, where the coefficients of the variables follow a pattern. So let's first find out what pattern it follows. Let's subtract the first term from the second term. So the second term is p plus 3q minus the first term, which is minus p, equals to p plus 3q. Then minus p is plus p. So we have 2p plus 3q. So this is the difference between the first and the second term. Now let's look at the difference from the second and the third term. So the third term is 3p plus 6q minus p plus 3q, which is the second term. Let's simplify this expression by removing the bracket. So it equals to 3p plus 6q minus p minus 3q. Remember, when you remove a bracket that has a negative sign in front, you need to change the sign of each term in that bracket. So be careful, we have two negative signs here. So it equals to 3p minus p is 2p, and 6q minus 3q is 3q. Okay, now you can see that the difference between the second term and the third term is also 2p plus 3q, which is the same as the difference between the first and the second term. You can also check the difference between the third and the fourth term, and the difference will also be the same, 2p plus 3q. Now we know that this series is an arithmetic series. So the first term of this series is t1 equals to minus p. The difference between the terms d is 2p plus 3q. Now that we know the first term and the difference, we can find out the 15th term and the sum of the first 15 terms. To find out the 15th term, t15, let's write the general term of an arithmetic sequence. Tn equals to t1 plus n minus 1 times the difference d. For the 15th term, n equals to 15. Let's plug in the values into this formula. T15 equals to t1 is minus p plus n is 15 minus 1 times d, which is 2p plus 3q. Let's simplify this expression. Minus p plus 14 times 2p plus 3q. Alright, let's remove the bracket. Minus p plus 14 times 2p is 28p plus 14 times 3q is 42q. So let's combine the p. It's going to be 27p plus 42q. So this is the t15. Now let's find out the sum of the first 15 terms as 15. Let's write the formula of arithmetic series as n equals to n times 2 times the first term plus n minus 1 times the difference, then divided by 2. For the sum of the first 15 terms, n equals to 15. Then let's substitute the values. S15 equals 2, n is 15 times 2 times t1. t1 is actually minus p, plus, again, n is 15 minus 1 times d. d is 2p plus 3q, then divided by 2. Okay, we need to simplify this expression. S15 equals to 15 times 2 times minus 2p is minus 2p, plus 15 minus 1 is 14. Then we have 2p plus 3q. Okay, so divided by 2. Now let's try to remove this small bracket here. S15 equals to 15 times minus 2p plus 14 times 2p equals to 28p, plus 14 times 3q equals to 48q, then divided by 2. Now let's combine the minus 2p and 28p, which is 26p plus 42q, divided by 2. Now let's remove the last bracket. S15 equals to 15 times 26 is 390p, plus 15 times 42q is 330q, divided by 2. So eventually we have S15 equals to 390 divided by 2 is 195p, plus 630 divided by 2 is 315q. Remember, both terms on top need to divide it by 2. So this is the final answer for S. You can also use the other formula to solve the Sn. Sn equals to n times the first term, t1, plus the last term, which is tn, then divided by 2. Okay, for n equals to 15, we have S15 equals to 15 times t1 is negative p plus t15 divided by 2. Now we have S15 equals to 15 times minus p plus t15. We've got it here. So let's plug in this expression, which is 27p plus 42q, then divided by 2. And then further, we can get 15 times 26p plus 42q divided by 2. And you see we are coming back to here. And doing the same thing, we'll eventually get S15 equals to 195p plus 315q. So we get the sum of the first 15 terms with another formula.